Hello, Honors Pre-Calc students. This is the day before your quiz. This is Thursday, and this is the review lesson in Pre-1.3. And the first thing you're going to see in your warm-up is a piecewise function. So remember, we did one of these earlier in the week, and this is where you have the graph in pieces. And so the first piece of the graph is a line. It's f of x, or y, is equal to 3/2 x minus 1. And the second part is the square root function. And we're doing the line for x values that are less than 0, and we're doing the square root function for values that are greater than or equal to 0 for the x. So I'm going to start with my line, and I'm hoping this will focus just a little better. And so for the line, we're going to start at -1, but remember, it says x is less than 0, so at -1 we're going to have an open circle, because when x is 0, your y value will be a -1, and we are not including that point because it is not equal to. And our slope is a positive 3/2. So normally I would go up 3 and to the right 2 and up 3 to the right 2, but I'm going to go down and to the left instead. 1, 2, 3, and left 2. And down 3, and I can't go any further. So I'm going to go ahead and draw that part of my graph. I need a straight edge. This is a line. And it goes through 0, -1, which is not included. And so I just have this little piece of my line. Alright, and so those are the x values that start at 0 and go towards -infinity. And then for our x values that are greater than or equal to 0, we're doing our square root function. And I'm going to change colors here just to be really clear. So I did the line in green, I'm going to do the square root function in pink. And so if I think about my square root function, if I plug in x is 0, if I'm thinking about a table, you can make a table, but the square root of 0 is 0. And this time 0 is included, it's greater than or equal to 0. If I square root 1, the square root of 1 is 1. The next perfect square will be 4, so that'll probably be the next one I choose. The square root of 4 is 2. And so 4, 2 is the next point. And the square root function is kind of, it is your parabola turned on its side, just the top half of it. And it goes all the way to the right. And so we have graphed our piecewise function. I have the line in green for x values that are less than 0. And I have the square root function in pink for x values that are greater than or equal to 0. So that is your warm-up. Examples, we have another piecewise function for examples. So we're going to start seeing more of those. I'm going to do this first part in green again. So f of x is equal to -3. That's just a horizontal line that goes through the y-axis at -3. But if you look, we're starting at x values that are less than -2. So less than -2. So here's -2 on my x-axis. This is a horizontal line that would go through the y-axis at -3. Oh, I drew this on the wrong graph. Oops. I'm on the wrong grid. Here we go. So -2 for x is where they begin, and we're going to go down to -3. And so normally this would just be a horizontal line that goes through the y-axis at -3. But we only want x values that are less than -2. So again, grab your straight edge. We're going to go x values that are less than -2, not including -2. And so there's the first piece of our line. I think that's a little blurry. All right, the middle function, f of x or y, is equal to the absolute value of x times 2. So this is an absolute value function with a stretch. And we are doing x values from -1 to +2. So remember, your absolute value function is a v. The vertex on this one is at 0, 0, and off to the side here, I'm just going to remind you, we're looking at functions in the form y equals a times the absolute value of x minus h, close your absolute value bar, plus k. And the h comma k is your vertex, and the a out front is like your slope. And so in this problem, our vertex is 0, 0. There's nothing with the x inside the absolute value bars. There's nothing tacked on the end. And so our vertex is at 0, 0. Of our v, and 0, 0 is in our domain, so I'm going to go ahead and put a point there. And then the A out front is like your slope. So this is like a slope of 2, except that it's not a slope because we need to go up 2 and over 1 both directions. So up 2 and over 1 both directions. And I want to make sure I stay within my domain. I only want x values from -1 to +2. So I'm at -1 right now for the left side of my x. And that point is included, so it's a filled in circle. And then when I get to x is 2, and right now I'm at x is 1, at x is 2, so up 2 over 1 again, I need an open circle because the 2 is not included. So I'm going to go ahead and graph my V shape here. And I'm not going to put arrows on the end because we're only looking at the pieces included in the domain. So far we have the line part graphed and we have the absolute value part graphed. And notice that we do have a jump here. We have x values starting at -2, and then there's a gap here in our domain where the next x value isn't until -1. And then last of all, I'm going to graph the y is equal to, or f of x is equal to a negative x minus 3, the quantity squared. You should be thinking that's a parabola, and it's also in vertex form. So this is a times x minus h, the quantity squared, plus k. And again, you see that hk form. And so our vertex on this one is the opposite of h. So our vertex is +3, and the k value is 0. I also know this parabola opens downward, and remember the a is not a slope on a parabola. And so this vertex is at 3, 0. 3, 0 is within the domain that we're given. So I'm going to go ahead and put a point at 1, 2, 3, 0. And my a is a -1, and so I know I'm going to go over 1 and up 1 for the first point of my parabola. And actually it's over 1 and down 1 because this parabola opens downward. And so when x is 2, we're at a -1, and when x is 4, we're at a -1. And for this parabola, 2 is the furthest left I can go to the left, and so that is just the left side of this parabola. It's that U shape. But to the right, I can go all the way till 5. And so right now, I just have a point at 4. So if I think about it, if I were to square 1, 1 squared would give me 1, so over 1 and up 1. If I square 2, so from this point, if I square 2, 2 squared would give me 4, and so it's going to be over 2 and down 1, 2, 3, 4. Or if you don't like that, you can plug in x is 5 into the function. 5 minus 3 gives you 2. 2 squared is 4, and this is a -4. You get the -4 this way as well. Okay, and normally we would draw an arrow on the end. It's a hard habit to break, but we're stopping at 5 because our range, or our domain tells us to stop at 5. Okay, and so this is your second piecewise function. All right, if you have any questions about this, talk to your neighbor. I'm going to pause here for just a minute and start a new video. Actually, maybe I'll finish up example 2 and then start a new video. Let's do that. Alright, so this is a function you have not seen before, at least to my knowledge, and it tells you that a parking garage charges $5 for the first hour and $1 for each additional half hour. And it's a little tricky there because it's each additional half hour. We need to draw a graph showing time versus cost. This is a step function. This is a function you have not seen before. And the deal is, if you pull into the parking garage and decide to leave, you're still going to pay the $5 for the first hour, even if you're only in there for a minute. And so it looks like steps when you graph it because these companies want to get as much money as they can from you. And so it's always rounding up. So on the x-axis, we're going to have time. That's your independent variable. Ignore my green circle. I was on the wrong grid earlier. And my y-axis is cost, which is going to be in dollars. Alright, so I'm just going to go, let's go by ones here. And so $5 is your first hour. And then we'll have $6, $7, $8, $9, $10. And then on the x-axis, I am going to skip some lines here. I'm going to go 1, skip a line, do 2 hours, skip a line, do 3 hours, skip a line, do 4 hours, skip a line, do 5 hours. And I'm skipping a line just because I want to make sure I can do every half an hour. Time in hours. Alright, so my x-axis, I have 1 hour, 2 hours, 3 hours, 4 hours, 5 hours with a space in between for the half hour. And on my y-axis, I have my money. So as soon as you pull in the garage, it's going to be $5. So we're starting on step 5. And for the first hour, you're going to be charged $5. So up until the first hour, even if you're in there just for a minute, this would be like just a minute, the little bit I have drawn. We're going to go all the way over to 1 hour. And if you're in there for 1 hour or less, so we're going to do an open circle at 5 and a closed circle at 1. If you're in there for 1 hour or less, it's only $5. But if you're in there for 1 hour and 1 minute, which happened to me at the airport one time, if you're in there for 1 hour and 1 minute, you jump up to $6. And so this is the jump. You have an open circle at $6. And then it's, let's see, $1 for each additional half hour. So that's the jump up to $6. And that's only the case for half an hour. So I'm only going to go to 1.5 hours, and I'm going to have a closed circle. Alright, so if you're in there just over an hour, up to an hour and a half, you're going to pay $6. If you're in there for just over an hour and a half, so an hour and 31 minutes, up to 2 hours, you're going to pay $7. And then we jump up a step. If you're in there for over 2 hours, you're going to pay $8, up to 2.5 hours. And from over 2.5 hours, open circle, to 3 hours, you're going to pay $9. And then finally, for 3 hours up to 3.5 hours, you're going to pay $10. And so this is your first step function. All right, I'm going to pause here and flip the notes over and